Hi guys, welcome to my YouTube channel Vaishak Physio. In this video, we'll be discussing in detail about ultrasound, that is your therapeutic ultrasound. So coming to the contents, by the end of this video, you will be able to understand what is introduction about ultrasound and definition of ultrasound, what are the indications, contraindications, different parameters of ultrasound, methods of applications of ultrasound, what are the different physiological effects, therapeutic effects, and the treatment procedure for doing an therapeutic ultrasound, and what are the dangers and precautions of ultrasound. So coming to the introduction, so basically ultrasound is just a ultrasonic waves. So it is a form of acoustic vibration propagated in the form of longitudinal compression waves at frequency too high to be heard by the human ear. So ultrasound is a type of sound, and all forms of sound consist of waves that transmit energy by alternately compressing and rarefying the material. So this basic ultrasound is having a frequency of greater than 20,000 hertz or 20 kilohertz. So that is the main reason why it is known as ultrasound. Ultrasound means it is a type of sound waves that is beyond the normal limit of hearing. So it is a sound with a frequency greater than 20,000 cycles per second, that is 20,000 hertz. Otherwise known as, it can be also said as 20 kilohertz. So this definition is based on the limits of normal human hearing. The humans can hear sounds with a frequency of 16 to 20,000 hertz. Sound with a frequency greater than 20,000 hertz is known as ultrasound. So that is beyond the 20 kilohertz that cannot be able to hear by our human ear is known as ultrasound. So generally the therapeutic ultrasound has a frequency between 0.7 and 3.3 megahertz to maximize the energy absorption at a depth of 2 to 5 centimeter of the soft tissues. So normally an ultrasound can able to penetrate up to 5 centimeter, like until your bone region. So we can able to give treatment for even your bone conditions, like after fracture, in order to improve your fracture healing and all, we can be able to give this therapeutic technique known as therapeutic ultrasound. So this is the ultrasonic compression and rarefaction wave. So already in the previous slide we already mentioned regarding the alternate compression and relaxation. So ultrasound wave is formed by alternate compression as well as the rarefaction of the waves. So this waves, so early, so in the earlier, like in the, this is the ultrasound head. So in this, nearer to the ultrasound head, the ultrasonic wave will be having higher frequency. Later, so once the space has been increased, so the waves will be getting attenuated, or the waves will be getting reduced according to the space. So ultrasound has a variety of physical effects that can be classified as thermal and non-thermal. So these physiological effects will be explained in detail in the upcoming slides. And so increasing tissue temperature is known as the thermal effect for your ultrasound. And what are the different non-thermal effects includes your acoustic streaming, microstreaming, and cavitations. So all these non-thermal effects will be helpful for altering the cell membrane permeability. In brief, ultrasound is a high frequency sound wave that can be described by its intensity, frequency, duty cycle, effective radiating area, and the beam non-uniformity ratio. So this is the attenuation property or attenuation property of this ultrasonic waves. So in the nearer to the ultrasound head or effective radiating area space, so the sonic waves or the intensity will be higher, and once it travels in space, so it will the free intensity will be getting reduced. So this properties of the ultrasound is known as attenuation. So it enters the body and is attenuated in the tissue by absorption, reflection, and refraction. So these are the physiological effects, or these are the principles of working of an ultrasound. So mainly it works under your absorption, reflection, refraction. So all these properties. So attenuation is greatest in tissues with high collagen content and with the use of high ultrasound frequencies. So if you are using high ultrasound frequency, attenuation will be greater, and with the higher collagen content, so in the bone and all, attenuation will be higher. The spreading of these ultrasonic waves will be higher in the tissues with high collagen content. So attenuation is the result of absorption, reflection, and refraction, and with absorption accounting for one half of the attenuation. So the attenuation is mainly almost by the absorption, reflection, and refraction, in which the almost 50% of the attenuation is mainly due to this absorption property of the ultrasound once it is getting entered into the tissues. So there is some properties, so that will be explained in the upcoming slide. So continuous ultrasound is generally used to produce thermal effects, whereas pulse ultrasound is used for non-thermal effects. Both thermal and non-thermal effects of ultrasound can be used to accelerate the achievement of treatment goals when ultrasound is applied to appropriate pathological condition at the appropriate time. So there is two properties or two effects, that is known as your thermal effects and non-thermal effects. If you want to achieve a thermal effects or a tissue heating, means you need to give continuous ultrasound. And if you want to have some non-thermal effects, meaning in order to stretch the collagen tissues or for the fracture healing and all, you can use this pulse ultrasound. So these are the two modes that is seen in the ultrasound: continuous mode and pulse mode. And this is the attenuation of different soft tissues, so in which the blood will be having 0.12, fat will be having 0.61, nerve will be having 0.88, muscles will be having 1.2, blood vessels will be having 1.7, skin will be having 2.7, and 4.9, cartilage 5, and bone, that is 13.9. That means those with higher collagen content, like your bone, cartilage, and all, will be having higher attenuation properties. And coming to the properties of ultrasound, so mainly attenuation is a result of these properties. So the first property include your absorption. So mainly absorption is the process of conversion of vibrational energy into a heat. So this process, the incident, this is the incident wave, and few waves will be reflected. So if you are giving ultrasound, so this is the tissue interface, that is the region of your skin in which you are going to treat the patient. So this tissue interface. So once you are giving a ultrasound, so this is the media one. So this is the air media, and this is the tissue or your skin media. So this is first media, and this is the second media. So once you are giving an ultrasound, few of the ultrasonic waves will be reflected back to the ultrasonic head. So if there is a gap between this tissue interface, so between the ultrasound and the tissue, so if there is a space, or if this tissue interface is irregular, means if you are giving a direct contact method, so if you are giving an ultrasound in a direct contact method, means definitely there will be some waves that is reflected back to the ultrasonic head, so that will lead to damage to the ultrasound. So we need to be careful while giving this ultrasound. So during the application of ultrasound, we need to be having a direct contact between the skin as well as the ultrasonic head, and we will need to be moving in a circular or different manners. So we can use either transverse strokes or direct circulars. So like that we can use in our figure of 8 and all. So this is the incident wave, and this is the reflected wave. So this is known as reflection. And next property is known as your transmission. So transmission, so this is the ultra incident wave, and almost all of the waves will be transmitted. So this property is known as transmission. And the other properties include your refraction. So definitely, so it will not be transmitted in a 90-degree or linear manner. So few of the waves will be refracted from the normal transmitted wave. So this property is known as refraction. So this is the incident wave, and almost all of the ultrasounding waves will be transmitted by this property known as absorption, and in which few of the ultrasonic wave will be refracted from the normal 90 degrees. So these are the properties of ultrasound. So the attenuation occurs as a result of all these properties. So coming to the ultrasonic fields, a further consideration relating to the depth of penetration and intensity of ultrasonic beam in the diversion of beam into a near and far field. So this is the transducer head, and this is the effective radiating surface area. So the area that is nearer to the ultrasonic head is known as near field, and far away from the ultrasonic head is known as far field. So Fresnel zone and Fraunhofer zone. So this is the near field and the far field. So according to attenuation property, the intensity will be higher in the near field. Once it is going to the far field, it will be getting reduced. So this is the longitudinal cross section of an ultrasound beam. It has been divided into two fields, that is the near field and far field, Fresnel zone and Fraunhofer zone. So this is the another pictorial representation, and it has been again classified into transverse compression or a longitudinal compression. So compression, alternate compression and relaxation in a longitudinal pattern, and alternate compression relaxation in a transverse pattern. So if you are giving a treatment towards your bone, once the ultrasonic wave is almost going to reach the bone, means in the bones it will be moving. Alternate compression relaxation will be occurring in a transverse pattern, and in the soft tissues like your skin, superficial fascia and all, so all these soft tissues, the ultrasonic waves will be moving in a alternate compression relaxation in a rare fashion in a longitudinal pattern. So this is the ultrasonic fields in different tissues. So coming to the definitions, ultrasound refers to the mechanical vibrations which are essentially the same as sound waves but of higher frequency and are beyond the range of human hearing. So these are the different ultrasound machines. This is the pic which I took from this Chattanooga. So these are the Chattanooga machines. So these are machines that is manufactured in the USA. So this is one of the leading manufacturers of electrotherapy machines in the world. So this is the anatomy or basic parts or different parts of an ultrasound transducer. So it consists of your effective radiating area, front metal plate, and piezoelectric crystal. So this crystal will be deforming in order to produce these ultrasonic waves, and resonating chamber or resonating coil, and the baffle or insulator, and the metal housing, and the coaxial cable. So this is the anatomy of a typical ultrasound transducer or different parts of the ultrasonic transducer. So production of the ultrasound. So how these ultrasonic waves are produced in this machine. So ultrasound is generated by applying a high frequency alternate electrical current to the crystal in the transducer of an ultrasonic unit. So a high frequency alternating current has been passed into the transducer to the crystals. The crystal is made up of a material with piezoelectric properties, causing it to respond to the alternating current by expanding and contracting at the same frequency at which the current changes its polarity. So this crystal will be going for a deformation, in which once the current has been reaching this crystal, so this crystal is having a property that is known as a piezoelectric property, alternate compression relaxation, or the ability to expand and contract. So when the crystal expands, it compresses the material in front of it, and when it contracts, it rarefies the material in front of it. So alternate compression as well as rarefaction of the material in front of it will be happening, and this alternate compression rarefaction produces a wave that is known as ultrasonic waves. So because of the high frequency electrical current passed through the transducer to the crystals, this crystal will be having a property that is known as piezoelectric property, and because of this property, this crystal will be going for deformation by alternatively expanding and contracting, and later produces this alternate compression rarefaction motion, and because of this ultrasonic waves are produced. So this is the compression and rarefaction of the piezoelectric crystals. So this is the different waves which I already mentioned in the previous slides. So there are two waves mainly: longitudinal wave propagation pattern and transverse wave propagation patterns. So in the soft tissues, so there will be, so in all the tissues like your soft tissues and bone soft tissue, bonds and all, these properties or this physiology will be same, like alternate compression and rarefaction will be occurring. But in the soft tissues, this compression and rarefaction will be occurring in a longitudinal pattern, and in the bones, this same compression and rarefaction will be occurring in a transverse pattern. So longitudinal wave pattern for the soft tissues and transverse wave pattern for the bone tissue. So similar, all the properties will be same, like your the method of production will be same, like your compression and rarefaction will be occurring in both your soft tissues and your bone tissues. The properties of piezoelectricity, or the ability to generate electricity in response to a mechanical force or to change shape in response to an electric current, was first discovered by Paul Jacques and Pierre Curie in the 1880s. A variety of materials that are piezoelectric includes your bone, natural quartz, synthetic plumpium, zirconium titanate, and barium titanate. At this time, the ultrasound transducer are usually made up of plumpium zirconium titanate, because this is at least costly. This is the least costly and most efficient piezoelectric material readily available. So this is the state of art or basic needs or basic properties of an ultrasound machines. So this should contain a low beam non-uniformity ratio, that is a 4:1, high effective radiating surface area, that is nearly matches the size of an sound head or ultrasound head, and it should have multiple frequencies, that is 1 megahertz as well as 3 megahertz, and multiple sized sound heads, sensing device that sheds the unit when overheating, well insulated to be used underwater, output jack for combination therapy, several pulse duty cycles, high quality synthetic crystal, and it should have a transducer handle that maintains the operator's wrist in a neutral and relaxed position. It should have a durable transducer face that will protect the crystal if dropped. It should have a computer control timer that makes adjustment in a treatment duration as the intensity is adjusted, much like your endophoresis, or the treatment time adjusts according to the dose applied. So these are the basic things needed for a good ultrasounds. So coming to the indications, the first indication includes your myositis, that is inflammation of your muscles, fibrositis, capsulitis, bursitis, tendinitis, tenosynovitis. That means all your inflammatory conditions can be treated by these ultrasounds, both your acute conditions as well as your chronic cases. And sprains, strains, myofascial trigger points. So this is one of the ultrasound application in the food. In case of plantar fasciitis and all, we can use these ultrasounds. And if the patient is having any temporomandibular joint pains or dysfunctions, we can use the ultrasounds. Actually, this kind of ultrasounds machines are rare or less used in India. So these are the Chattanooga brand machines. And your can be also used for your muscle spasm, carpal tunnel syndrome, neuralgia, neuromas, scar tissues, osteoarthritis, and to reduce your joint contractures and all. So in case of your neurological conditions in nerve compressions, so carpal tunnel syndrome pain, neuropathic pain, as well as your musculoskeletal conditions and all, and it can be even used for fracture healing. So fracture healing as well as your other inflammatory conditions as well as your muscular condition, you can able to use these ultrasonic machines. Coming to the contraindications, acute and post-acute conditions, areas of decreased temperature sensation, or the patient is having lack of sensation in the particular areas, and areas of decreased circulations, vascular insufficiency, thrombophlebitis, that is the inflammation of your vein, and it is contraindicated in the eyes and reproductive organs. So these are the different contraindications. And pelvic immediately following the menstrual cycles. In case of pregnancies, if the patient is having any cardiac pacemakers, and in case of malignancies, and epiphyseal areas in young children, and total joint replacements, and those who are having infections. All these cases, ultrasound is contraindicated. And next is about the coupling media. So ultrasonic waves are not transmitted by air. There's some couplant which does transmit them must be interposed between the treatment head or transducer and the patient's skin. So there is something that is known as couplant or coupling media. So the couplant should be used for the treatment of ultrasound. So the some coupling medias and their efficacy of transmission includes your aquasonic gel that is having 72.6% of efficiency of transmission, glycerol having 67%, distilled water having 59%, liquid paraffin having 19%, petroleum jelly and air is having 0%. So this means that air is not a proper transmitter of these ultrasonic waves towards the body. So that is the reason why we should not switch on this ultrasonic machine in the air. So first we need to apply some couplant and we need to keep in the patient's or client's affected region. Then only we need to switch the ultrasonic machines. Otherwise, if you are keeping switch on in the air, means it may lead to a reflection of these ultrasonic waves back to the crystals, and it may lead to the damage of this ultrasonic head. And so by concluding like your efficacy, the maximum efficiency of ultrasonic coupling media is mainly for the aquasonic gel that is having 72.6, and the least efficiency for your petroleum jelly and air that is having 0%. So mainly in our physical therapy fields and all, we will be using the aquasonic gel that is almost blue in color. So coming to the technique of application of ultrasounds. So first, before for going for the treatment procedures and all, we will be using this self-testing procedure. So how we will be testing whether this ultrasound is working or not, how we can able to find. So that can be found by testing these machines. Prior to any treatment, it is sensible to check that there is an output from the machine. This can be done by placing the treatment head just below the water surface in a suitable container and observing the disturbance that is known as ripples which appears in the water. So this apparatus should be on and off with the treatment head below the water. So this is how you will be testing the apparatus. This is known as a self-testing or self-testing of this apparatus. So in this, before starting a treatment to the patient, we will be checking it with a container filled with water and alternate on and off. So during switch on, because of the transmission of the ultrasonic waves, we can able to see the ripples or bubble-like stretches that can be seen over the water surface. So this is how we can able to find the machine is perfectly working. So the first method, there are different methods like your direct contact method, your water bag method, or a water bath method. So all this method can be used according to the situations. The most commonly used method is your direct contact method. If the surface to be treated is fairly regular, then a coupling medium is applied to the skin in order to eliminate air between the skin and the treatment head and transmit the ultrasonic beam from the ultrasonic head to the tissues. So directly we will be applying gel to the patient's skin, and then we will be applying this ultrasonic head on the that coupling media. So then the air between your skin and tissue interface will be less. The treatment head is moved in small concentric circles over the skin in order to avoid concentration at any one point, keeping the whole of the front plate in contact with the patients. So we should not remove the contact between the skin as well as the ultrasonic head, because if you are keeping this ultrasonic head in the air means it may reflect back these ultrasonic waves back to the crystal and finally lead to damage. So in order to prevent that, we should always keep moving in either in a circular manner or figure of 8 or transverse circles. So this technique is suitable for areas up to 3 times the size of the treatment head. Large area should be divided and each area should be treated separately. The size of the area and its exact location should be specified on the treatment head. So this is the direct contact method. So this is the skin tissue interface, and in between your skin and the treatment head, ultrasonic head, you need to use this couplant. So mainly we will be using a aquasonic gel which is having higher transmission effect. So this is the direct contact method. So this is an example for of direct contact method in the angle region. So usually this angle region and all we will be going for your water bag method, because this area is almost like an irregular surface because of the because of the presence of your malleolus. So this is how you will be applying the, or you will be doing an ultrasound in this manner. So these are the different manners or methods of applications. So either you can move your ultrasonic head in these concentric circles, or you can use this in an overlapping circle. So you can move the ultrasound head in this manner. So overlapping circle, or you can use the ultrasonic head in the figure of 8, or you can use in a manner of transverse strokes. So the most common method of application will be your concentric circles, in which we'll be keeping on moving the ultrasonic head in a concentric circle manner without being stopped. So next method include your water bath method. So when direct contact method is not possible because of irregular shape or a part, or because of tenderness, a water bath method may be used. As the part to be treated is immersed in water, this can only reasonably be applied to the hand, ankle, and the foot. So in the last slide I already mentioned in the malleolus region and all, which is irregular in shape. So we can use this method instead of direct contact method in order to prevent the damage of the crystals inside the ultrasonic head. So a water bath filled with degassed water is used if possible. Ordinary tap water presents the problem that gas bubbles dissociate out from the water, accumulate on the patient's skin and the treatment head, and reflects back to the ultrasound beams. So degassed water is distilled water, or degassed water is mainly used in the water bath method of treatment of ultrasound. So rather than the normal ordinary tap water. So because if you are using ordinary tap water means will because of uh, presence of gas bubbles. So these gas bubbles may come towards the patient's skin and the treatment head, and because of this it may cause the reflection of ultrasound beam back to the crystals, and it may lead to damage of the crystals. So if tap water has to be used, then gas bubbles must be wiped from these surfaces frequently. So if we don't have any degas water, so we will be using, or we can use ordinary tap water, but we need to frequently wipe off these gas bubbles or air bubbles frequently from the surfaces. So this is the water bath method, or water bath method can be used for your foot, your ankle, and your hands, and all those surfaces which are irregular in shapes. So this is also one example for your water bath method. So the patient is seated and put in a water of a comfortable temperature in such a position that is suitably supported. The treatment head is placed in the water and held 1 centimeter from the skin and moved in a concentric circles, keeping the front parallel to the skin surface to reduce the reflection to a minimum. If the patient's hand is to be immersed in water bath while the application is active, care should be taken to minimize the exposure to any reflected or scattered ultrasounds. This can be done by wearing a dry knitted glove inside a waterproof rubber or a plastic glove. So next method includes your water bag method. So another method of applying ultrasound therapy to an irregular surface which cannot conventionally be placed in the water bath is treated with a plastic or rubber bag filled with water, forming a water cushion between the treatment head and the skin. So rubber bag filled with degassed water can be used. All visible air bubbles should be squeezed out before knotting the neck of the bag to seal it. So this is also another type or the third type of method of application of ultrasound. So similar to your water bath method, this water bag method is also used for treating an irregular surface. So regular surface will be treated with your direct contact method and irregular surface will be treated with either with your water bath method or water bag method. So this is the water bag method. So in this you can able to see this water bag will be filled with a degassed water and the skin and the bag interface you can able to see here also we need to apply the coupling medium as well as the interface between your water bag and the treatment head. So in between your treatment head and water bag as well as in between your skin and water bag we need to apply the coupling medium that is your ecosonic gel. So in this diagram you can able to see they are giving treatment for their medial malleolus of your left foot and this we can able to see the gel is applied in between your ultrasonic head and the water bag as well as the skin and your water bag. So both regions, yeah, we are applying this coupling media for the better transmission of ultrasonic waves into the affected region. So this particular water bag method is otherwise known as bladder method or bladder technique. A coupling medium has to be placed both between the rubber bag and the skin and between the rubber bag and the treatment head to eliminate any air. The bag placed on irregular surface is then held with the help of patients or others. Treatment head pressed firmly onto the bag so that a layer of water about 1 centimeter thick separates it from the surface or that is the body. Inevitably, some bubbles will form and it is important to ensure that these are in the sides of the bag and not in the region transmitting the ultrasound. The treatment head is then moved over the surface of the bag. So by this, we are concluding the first part of the ultrasound video. In the next video, we will be explaining in detail about the different parameters, therapeutic effects, physiological effects, dangers, as well as the precautions of ultrasound. Thank you for watching this video. Please do subscribe and share this video to your physio friends and fraternity. Thank you.